A particle is projected at 20 meters per second at an angle of 30 degrees from the top of a cliff, which is 30 meters high. We want to find how long the particle is in the air before it lands in the sea. Here I'm going to take the upward direction as positive. Gravity, remember, acts vertically downwards, and here we're going to take it as 9.8 meters per second squared. When considering how long before the particle hits the sea, we're considering vertical motion. We collect the information using SUVAT in the normal way. This is 30 meters below the point of projection, so the point of projection is taken as the 0 point, 30 meters below, with upwards taken as positive, means that S is minus 30 meters. So minus 30 meters represents 30 meters below the point of projection. The vertical component of velocity is this component. We need to resolve the initial velocity into components horizontal, and this will be the cosine, and vertical, which will be the sine. We're interested in the vertical here, and the sine of 30 is a half, so this is 10 meters per second. Acceleration is minus 9.8 meters per second squared, and we want to find t. We can use S equals ut plus a half at squared. So minus 30 is going to be 10t minus 4.9 t squared. 4.9 is half of 9.8. Rearranging, this gives 4.9 t squared minus 10t minus 30 is equal to 0. We can use the quadratic formula to solve this, so we get 10 plus or minus the square root of minus 10 squared, take away 4 times 4.9 times minus 30, all divided by 2 times 4.9. So this is 10 plus or minus the square root of 688 over 9.8. And this is equal to minus 1.66 or 3.70. Clearly time can't be negative, so the time taken must be 3.70 seconds, correct to 3 significant figures. We now want to find the speed with which the particle hits the sea. Again, upwards is positive. Gravity we know is downwards, and 9.8 meters per second squared. The horizontal component is 20 cos 30, and the vertical component 20 sin 30. We know the horizontal component will remain constant throughout the motion, so will always be 20 cos 30. If the particle is here, the horizontal is 20 cos 30, and we want to know the vertical. So considering the vertical motion, collecting our information as usual using SUVAT, we know it hits the sea 30 meters below projection. The initial velocity is 10 meters per second upwards, so this is positive. We want the final velocity, and gravity is minus 9.8 meters per second squared. We can use v squared is u squared plus 2as, so v squared is going to be 10 squared plus 2 times minus 9.8 times minus 30. And this calculates to give us 688. We want the speed, so we consider a right-angled triangle. 20 cos 30 is the horizontal component of velocity, and the square root of 688 is the vertical component. The speed will be the length of the third side of this right-angled triangle. So using Pythagoras' theorem, v squared is going to be 20 cos 30 squared plus root 688 squared, which is 688. And this calculates to give us 988. So v is the square root of 988, which is 31.4 meters per second, correct to 3 significant figures.